All right, so I'm Matt Garrett. I'm one of the developers at CR Tech, and I'll be talking about OpenTD, as Brent mentioned. So what is OpenTD? Well, it's an application programming interface, or API, for Thermal Desktop. It allows you to connect your programs to Thermal Desktop and control TD automatically. You will find that OpenTD is installed with Thermal Desktop 6.1, and your programs can access all of the features in OpenTD simply by referencing the OpenTD DLLs, which you will find on your system once you've installed 6.1. You can use any language that can talk to Microsoft's .NET framework to work with OpenTD. We recommend and support C#, but you could use MATLAB, Python, or any number of other systems that work with .NET assemblies. OpenTD is strictly version controlled. And what I mean by that is the interface that we release won't change. Or it'll only change with each new version. There won't be features added or subtracted mid-year. And so also your programs won't break when we release new versions, because the TD installer will install the OpenTD DLLs, the new ones and the old ones, side by side each year. And it's a fully documented API. You will find a getting started guide and a class reference are installed with Thermal Desktop. And then you can go on the forums to find additional examples. Okay, what can you do with it? Well, you can connect your program to Thermal Desktop, and you can connect in two ways. You can attach to an already running instance of AutoCAD, or you can start a new instance of AutoCAD. And your program can connect to just one instance of AutoCAD or many instances simultaneously and control them simultaneously, trading data, doing whatever you need to do. Once you've connected to Thermal Desktop, you can create, query, edit, and delete most Thermal Desktop entities. Some examples are thermal network entities like nodes and conductors, finite difference surfaces, finite element meshes, although there's only limited support there in 6.1. You can create them and you can delete them, but you can't query or edit them. Almost all of FlowCAD, so lumps, paths, ties, F-ties, etc., case sets and orbits, thermophysical and optical properties, and many, many more things that I haven't listed here. OpenTD has robust support for units, symbols, and expressions. So anywhere in Thermal Desktop that you can control units, you can control those units in OpenTD. And anywhere that you could use an expression instead of a number or a symbol as part of that expression, you can do the same in OpenTD. Of course, you can run cases. And then once you've run those cases, you can explore, compare, and plot the results that you generated in save files or CSRs. So those are some general uses for OpenTD, but I'll mention some specific use cases that we've already seen, either external to CR Tech or internal. You could translate thermal desktop models to and from another thermal model format. And indeed, ESA is about to release a step task to Thermal Desktop Translator that uses OpenTD. And James Etchells at ESA is working on a thermal desktop to StepTAS translator now. You could modify and run models as part of an optimization loop, or for some other purpose, like to create reduced order thermal models, or within some sort of other analysis framework. And LoadPath is currently doing that in Veritrack using OpenTD to create reduced order thermal models. And we here at CR Tech are using OpenTD internally to explore integrating thermal desktop into other analysis frameworks. Another use case that we've heard mentioned is creating boundary surfaces in your model based on bitmap data taken from IR cameras experimentally. Something else you could do, of course, is to work with the results from hundreds of cases and produce statistics from those results. And the cases themselves could have been automatically generated and run using OpenTD. You could compare save files and CSRs just to see specifically what's different between these two save files, for example. You could create a simplified front end for controlling thermal desktop and then hand that model over to someone who's not familiar with thermal desktop and allow them to run the model. You could capture screenshots of a model for a report. And what I imagine here is that you set this up once, you're taking screenshots of the model with full layer control and viewpoint control, and automatically generate the bitmaps or place them right into a Word document in your program. And then when the model changes and you need to update the report, instead of having to go and manually do all of those steps again, you'll just run your program again and redo it. You could clean up a model by querying it and automatically putting entities onto layers and into submodels, etc. Or you could run cases in a batch mode and email yourself after each run finishes with the results of the run. Okay, I'm going to show you some actual demos. And actually, this bitmap here is a demo of sorts. This is a model created with OpenTD that looks like our CR Tech logo. The first demo that I'd like to show is going to be really, really simple. What I want to do is just show you how easy it is to create an OpenTD client program. So I'm just going to create one from scratch. And it'll be the last, well, almost the last time that I show you any source code. But I didn't want you to be watching these more complicated demos and think, you know, that's all well and good, but I bet it's really complicated. So I'm going to show you how easy it is to do this. So I'm going to start Visual Studio, and I'm going to create a C# console app. I'll just accept the defaults here. And I have to move the GoToWebinar window out of the way. Let me just make sure I can do that. There we go. All right, now that I've got a C# application, I'm going to add a reference to the OpenTD DLL. I'm going to look for it on my C drive in the global assembly cache. I've added it. Now we'll see that it's added here in references. Once it's added, I can use its namespace. Now that I'm using that namespace, I can create a thermal desktop object. That represents one instance of thermal desktop. And when I call connect on that with no options, it's going to just start a new instance of thermal desktop. Once that's started, I'm going to create a node. And then I'm going to set the node comment. Typo and all. Then I'm going to update that on the thermal desktop side, and I'm going to call zoom extents in thermal desktop. Okay, so that's an entire client program in OpenTD that we've made from scratch. I'm going to compile and run it, so we should see it running in a moment. There it goes, and then that should start Thermal Desktop. And once it starts, we should see that we zoom extents and have a node sitting in the center of the screen. And if we edit that node, we should see that comment that I added. So we'll edit it. Oops, didn't like that. And we have hello world typo and all. Okay, let's move on to the more interesting demos. Obviously, if you were just making one node and editing its comment, you probably wouldn't use an API to do that. APIs make sense when you're doing tedious and repetitive work. So I've invented a
Matt, can I
tedious
interrupt
and
with a quick question here? It's appropriate at this time.
Sure.
First of all,
sure.
can you connect to an already open instance of Thermal Desktop?
Yes, you absolutely can, and I'm about to do that.
Okay. Second question is, do you have to have AutoCAD open in order to use TD? Is there a way to do it without ever opening AutoCAD?
No, we can't currently interact with a drawing file without opening AutoCAD. You can use OpenTD and interact with save files and CSRs without opening AutoCAD, but not the drawing database.
Thank you.
You're welcome. Okay, so I've invented a repetitive and tedious task. This comes from the Getting Started guide, and what I'd like to do is create a line of nodes in a sinusoid pattern with connected by conductors, and each one is going to be in a random layer that I'm going to generate with a random color that I'm going to generate. So when I click go here, this client program is going to connect to this instance of AutoCAD based on the name here, this sinusoid drawing name, and it should do that for us. So let's see. There we go, creating the conductors, and then it's going to change the visual style and then restore an isometric view. You have some control over visibility using OpenTD as well, so you can change visual styles and change your viewpoint. And you can see that it made all of these layers all with, if I can, well, I can't do it, but I think it's clear that it made them all with different colors. So let's look at the next demo. Oh, actually, I'm going to cancel closing AutoCAD that way. I set this one up so that if I hit X on the client program, it's going to close AutoCAD like that. So we've given you that control as well in OpenTD, that you can close AutoCAD when you need to. Okay, for the next set of demos, I'm going to use this OpenTD Demos version 6.1 program. And you can download the source for this program from the forums. For the first demo, I'm going to create a robot shape out of finite difference surfaces and bring up a little control panel. And the idea here is this shows how we could create some sort of simplified front end to a model. In this case, all we're doing is positioning the robot, but I could have added buttons or something that would run cases or do more complicated tasks. And when I hit X on this, it's going to delete those entities. There we go. The next example is going to create a finite element mesh. And then it should give us a little dialog, there we go, to delete that mesh. The next one is an example of the additional parameterization options that are available to you using OpenTD. Of course, Thermal Desktop features really good parameterization options already with symbols and property aliases, etc. And symbols are great if you want to control the position of something, or if you want to control the length of something. But if you wanted to change the topology of your model, you know, how many chillers, how many engines, etc., I think you're probably out of luck with symbols. Maybe some smarter person than me could figure out how to do that with symbols, but I don't know how to do that with symbols. But it's easy with OpenTD, so I'll demonstrate. I'm going to make a truss out of nodes and conductors. There we go. And I can change things like the length, you know, just the same sort of thing I could do with symbols, of course. There we go. We have a new longer truss. But then I could also change the topology. I could change the number of truss sections. So I'm going to reduce that to 4. So I imagine this giving new options for optimization loops, etc. And when I hit X, it should delete. Okay, the next demo uses a different drawing, so I just need to fetch it. Okay, this drawing is going to use named views. So these are AutoCAD named views that I've created previously to allow me to restore those views of the model and then call the AutoCAD capture graphics window command to return a bitmap object to my client program. Oh, looks like I had the wrong drawing opened. So it robustly, instead of connecting to the one here that I guess was the wrong one, I must have opened it from a different location. It is just going to open a new one for me. I have it set to an auto connect mode that tries to connect, and then if it can't connect, if it can't find that drawing open, it just opens it for you. Okay, so we've opened the correct drawing now. They look very similar, of course. When I click the Get Next Screenshot button, it's going to restore a named view. It's going to cycle through different named views, and then it's going to call Capture Graphics Area, and then pass that information as a bitmap, a C# or a .NET bitmap, over to my client program, which could then put it into a Word document or a PowerPoint. Instead, for this demo, I'm just going to display that bitmap here to prove that I got it. So let's see if it works. There we go. I can cycle through and do another one. I'll do one more. And then when I hit X, it should close that model. And I'll just close this other one manually that I opened erroneously. Okay, so I think I opened the right model here, but I have a feeling I opened it from a different location as well. So we'll see what happens. This, this next demo is going to demonstrate modifying an existing model. Maybe while I'm talking, I'll just start up the demo and see. Yeah, so it wants to load a different model. So we'll talk about it as we
can I interrupt?
Yeah.
Because there's a good question right now for what you're doing is, can you configure OpenTD to connect to whichever drawing is open if multiple ones are open? Just have it automatically go to the currently active one?
No. The closest you could do, so you can't just say, go and find the one that is that has focus. You can't do that. There is an AutoCAD command that I've added. It's RC OpenTD v61. So if you issue that command in AutoCAD, it'll then ask you for a communications pipe name. So then you give it some unique name, and then you could tell your client program to go find that pipe. So you can do kind of what you're asking, but in a roundabout way.
Thank you.
You're welcome. Okay, so this this particular model, it's an avionics box. It's an aluminum box with a motherboard, a bunch of daughter boards, chips on the daughter boards, and it was created and given in this scenario. It was created and given to you, but everything is on layer 0, and in the same main submodel. And so now you're faced with the painstaking job of organizing this into a thermal model you'd actually want to use. And you want to put the box into its own layer and submodel, the same with the motherboard, same with each daughter board, maybe named based on position. All the chips you want to put onto their own layer and submodel. And then you wanted to add heat loads to the chips and have those heat loads parameterized with a symbol. And the model, I don't think it contains any symbols right now. Yeah, there's no symbols whatsoever. I'll bring up the layers too so we can see that it is all on 0. Yeah. Okay. So what we've done is instead of doing this manually, we've done the more fun task, I think, of writing a program using OpenTD that will go through and do all of those things for us. So I'm going to say OK here. And then the output, unfortunately, is stuck on another monitor. So I'll tell you what it says. It says organizing model, and it's about to find the chips, I think. There we go. OK, so it's coloring the chips, building those layers. And you can see that it colored the daughter boards in sort of a cycling color pattern. If we look at the names of those daughter boards, this is board 1, and this is board 2, etc., based on that position. And if we were to edit one of these heat loads, we would see that it used an expression for the heat load value. And even though the model is in English units, we happen to know that the heat load was in watts, and so it used the correct units here in the expression, just like you would do using using Thermal Desktop interactively. And if we look at the symbols, you see it created a heat load symbol that it's now using. Okay, I'm going to close this one up. And close the one that I erroneously opened. And I think I'm done with this demo as well. So yeah, we'll get rid of that. The next one's a little more complicated. It'll just take me a second to set it up. Yeah, okay. So what we've got is 2 drawings. Right now they're identical. They represent some sort of lump and path network, some sort of system level network. And the task is to take one of these subnetworks, and in this reduced model over here, replace the subnetwork with just a single path. And then we're going to tune the flow area of that path to the response of the full network over here. Okay, so let's find our client program. Here it is. The client program has gone and queried the model to list the lumps and the paths. And I'm just going to select these. So this is lump 2, and this is lump 11. I don't know if that comes through in the webinar. I'm going to pick lump 2, and then I'm going to pick lump 11. This is just the kind of weak UI that I created in this client program as a demo. And I'm going to click reduce section, and it should go and turn that into a path, a single path. There we go. And then it brought up a window on another monitor, so we'll bring that over. And when I click Tune Reduced Model, it's going to run the case that I selected. There happens to only be one case. It's going to run the case that I selected in the master model. Over here, we should see it doing that. And then it's going to grab the upstream and downstream pressures on our reduced section, or to be reduced section. And then it's going to start trying flow areas in the reduced area here and comparing those. And we're only going to let it do 5 iterations since this is just a demonstration of how OpenTD connects to multiple models and reads their results. Probably should have just let it do 3 iterations. And then I think it's going to rerun with the best one. Okay. All right, I'm going to close that up. And we'll go back to the PowerPoint for the last demos. The last demos, I'm not going to run them live because they're not that exciting to see them run. They're demonstrations of exploring results using OpenTD. So let's look at the first one. I've included a little bit of source code here. I'm not going to talk about it in any detail. I just wanted to point out that I didn't need a lot of source code to do the task that I wanted to do. And the task that I wanted to do here was to pull temperature and heat rate data for one node from one case, okay? And then create a plot of that. And so I was able to do that in just a few lines of code. And you'll notice that nowhere in this code did I name the chart, or did I name the series, or did I say anything about units? But we ended up with units in our axes labels. We were plotting two different dimensions, temperature and heat rate, and it automatically put them onto different axes. It automatically labeled the plot. It automatically labeled the series. These units that it's using, they're actually not necessarily the units on the save file. They're the units that somewhere at a higher level we had asked this program to always use, which we could override, but that's what we happened to ask for. So that's the first demo of working with results. Here's another one. Again, not a lot of source code involved. But this one goes and finds the average temperature for one whole submodel from one save file. Okay, using some special classes, there's something called an average data array that knows how to find average data. And then it just acts like any other data array when you plug it into a plot, but I won't go into any more detail there. And then this last one looks like a little more source code, but it's doing quite a lot more. This one is searching through 4 cases and finding the max and min temperatures for one submodel across those 4 cases. Okay, and so we ended up plotting a temperature envelope for the entire submodel, and you'll notice that the hot temperature comes from node 5, and the hot beta 60 case, and the cold temperature happens to come from node 4 for the cold beta 60 case. And that's it for demos. I wanted to talk about some limitations of OpenTD so that you're aware of them before you dive in and use it. It might work for you in earlier versions of AutoCAD, 2015 and 2016, but we are noticing bugs in 2015 and 2016, and so we recommend AutoCAD 2017 or greater. And then you won't find support in 6.1 for finite difference solids. You won't find full support for FEMs, as I mentioned. You can only create and delete them. You won't find support for compartments, and you won't be able to do any post-processing within Thermal Desktop. You can work directly with the save files and CSRs as I just demonstrated. And then all 4 of these items will be in 6.2. To get started with OpenTD, I would recommend that you go into your TD install directory and then look in the manual directory, and you'll find 2 documents, a getting started guide and a class reference. And then when you're ready, I would take a look at the forums where you'll find, for example, a simple Python example and a simple MATLAB example, and the C# demos that I've been using today. And that's all I have. So are there any questions?
So I have a few questions that have been typed in during the course of the webinar. I'd also like to remind you that if you would like to be unmuted so you can ask a question verbally, raise your electronic hand and we will get to you. Otherwise, we'll work on the typed questions as we receive them. First one, Matt, can you pull up the standard check plots for K, alpha, E star, and so forth as part of, maybe a cycle through a model and have it pull those up?
No, not yet. That is planned for 6.2.
Okay, thank you. Some other questions about compatibility of versions with things like the Intel Fortran compiler and Visual Studio. Any reference sheet on what versions of those you're limited to?
Okay, so I don't know how OpenTD interacts with the Intel compiler.
I don't really think there should be an interaction on that one. Yeah.
That's what I think too. When you run a case using OpenTD, you are instructing Thermal Desktop to run a case. And so if Thermal Desktop works to run a case on your machine, OpenTD should too. The only caveat there is if you happen to be running your client program in debug mode, that tends to mess with the environment. And on some people's computers, that has screwed up Cinda. But the answer there is don't run in debug mode. And then the other, with regard to Visual Studio, we use the .NET Framework 4.0. And so you need a version of Visual Studio that supports at least .NET 4.0, which that's not a difficult requirement to meet. I think Visual Studio 2010 and above will meet that requirement.
Okay, another question here. Why can't you edit finite? You can create finite elements. Why can't you edit them?
We simply didn't have time to add that functionality into 6.1. I think the thing to understand is that there's been 25 years of development on Thermal Desktop, and it's got a ton of functionality. And exposing all of that all at once in an API it's simply a daunting task. And so we had to break it up into stages and try to prioritize what needed to be done. And that functionality just didn't make it into 6.1, but it will be in 6.2.
Okay, another question is on the current ways for connecting, such as COM for connecting to other codes like MATLAB and Excel. How is this different, or how does it relate?
Sure. Okay, so this will ultimately replace the COM-based API. It's already far more capable, allowing creation and querying of entities, for example. But because of the way we're implementing it, we're implementing complete blocks of functionality in OpenTD. And the COM interface was implemented in a more, it was implemented as bits and pieces from all over the Thermal Desktop interface. And so there are some things that it does that we haven't gotten to yet because we're implementing things in such a systematic way versus the sort of scattershot way that the COM interface was implemented. So there's a few things that it still does. I think in 6.2, and I haven't looked into the feasibility of this, I think in 6.2 I will try to add an OpenTD command that will just pass through any COM command, any of the existing COM commands. And then we can say with authority that it really does, it really is a superset of the COM interface.
Okay, another couple of questions. Can you create pipes on complex center lines, such as splines or curves, instead of just straight lines?
I am not sure. I don't think we can right now. I think we can only do straight lines. If you create the spline manually, you can refer to it in OpenTD. I know that's not great. That's not a great anscer, but
well, part of the answer for that, of course, is that this is an OpenTD connection, not an Open AutoCAD connection. So you have to have a separate API to develop the CAD objects upon which you might use an OpenTD pipe.
Yeah, and that's exactly right.
Okay, another question is, does its capability of reading the save file include registers?
Yes, absolutely. There's a get registers method.
Another question is, does it, when it's reading post-processing, does it read CSR folders faster than EasyXY does?
I haven't tested that. It's using the same underlying DLLs that EasyXY uses to read the CSR, but it has different overhead on top of that than EasyXY. So there's a chance that it might run faster than EasyXY.
Okay, another question is on the demos you just presented. Is there source code available for those, or are they tutorial format?
Yeah, all the source code is available for all of those demos on either the forum or in the Getting Started guide.
Okay, that not as a tutorial though, more of an explanation of what's going on there, I think was the other part of the question.
Oh, I'm sorry. Yeah, so the Getting Started guide contains several demos in tutorial form, including the Sinusoid and the really basic one that I did at the start, the Hello World. The other demos are all available just as source code, but it's pretty heavily documented source code.
Thank you. Another question is, what other languages can you use besides C# in writing a connection?
So the key to look for is, if you're interested in using language X, does language X have a way of referencing .NET 4.0 assemblies? If it does, then you can probably use it with OpenTD. The caveat is, for example, I've gone and I've rewritten one or two demos with MATLAB and with Python, and in both cases, the syntax becomes a little more cumbersome than in C#, because I make use of some syntactic sugar in C# that I haven't figured out how to replicate in MATLAB and Python. And actually, the other, probably more important thing is MATLAB says that it supports .NET, referencing .NET assemblies, but we've run into a few bugs with the way it handles .NET enums, and they result in really a loss of functionality in trying to use MATLAB to access this. And all of that is explained on the forum in my MATLAB example.
Thank you. Yeah, I think the upshot then is that the lowest hanging fruit is C#, the easiest to use, more complete, but any .NET 4.0 compatible language should at least be worth an attempt.
I completely agree with that statement.
Another question on, can you highlight some of the differences between OpenTD, which is, and TD API v1? And just to clarify for folks, TD API v1 is the name for OpenTD before we had that name. So they're essentially the same thing, just two different versions between the 6.0 and the 6.1. So I guess the question is, what changed since 6.0 was released in the beginnings of the API?
Sure. Yeah. So this feature summary shows what we've implemented in TD API v1 in the v1 columns, and what we've added in OpenTD 6.1 and then also what we plan for 6.2. So in 6.1, we added aliases, assemblies, AutoCAD variables, contactors, domains, etc. I think one of the heaviest hitters here is that we added finite difference surfaces in 6.1 and some sort of support for finite element meshes.
Okay. Have another question here is if I write a application in OpenTD right now, what happens when 6.2 comes out?
Yeah, okay. We will continue to install the 6.1 DLLs unchanged from when you wrote your application with each new version of Thermal Desktop. And so, and then each OpenTD version uses a different namespace. And so your program should continue to run completely unchanged on the new platform. It'll just ignore the presence of OpenTD 6.2 unless you want to use OpenTD 6.2. And we'll continue to do that as long as we can. The issue would be if Autodesk makes a change or if some other change comes along that makes it impossible for us to continue to adapt 6.1 to work with, 6.9 or whatever version we're on. So eventually we might retire a version, but it shouldn't happen, one version later or two versions. It should be, further in the future.
Very good. Thanks, Matt. I think we're reaching about the end of the questions here, so appreciate your time presenting this. Appreciate everyone's time watching.
Yeah, thank you, everybody.
This is obviously a brand new. Well, as was intimated, we had an earlier version in 6.1 and 6.0 that we weren't very loud about because it was just the beginnings. But this is obviously with 6.1. Quite a startling new feature here and a lot of possibilities. So we understand that there's going to be a lot of continued questions. So I'd welcome you to go ahead and write to us if you have any other or give a call. We also would appreciate suggestions of things that we haven't thought of that you think would just make your life better with 6.2. We'd certainly like to consider that for the development plan.